Hey, I got a great question from section 9.5. Ends up being question number 3. And 9.5 is all about bootstrapping, which is a method that's kind of distinct from all the other kind of inference testing that we've been doing, in that it's something called non-parametric, right? We don't have to know it. We don't have to have any assumptions satisfied to be able to do it. If you think about some of the other techniques we have in chapter 9, they require the sample size to be a certain not too big but not too little either, and before you can use that type of inference method. But bootstrapping allows you to do statistics even when the sample size isn't the right size, or your other assumptions aren't satisfied. Okay, and this question doesn't go through all the full bootstrap method. But the key part of the bootstrap method is it takes a random sample, albeit here small, right, of males, and it's got the heights. And what bootstrap does is it like samples the sample, which is kind of a weird idea. It's going to sample the sample. So pretend these numbers are all like in a little bag, okay? And you put them in the bag, you shake them up, okay? Now, to bootstrap, what you do is you're going to choose the same number. A bootstrap sample has the same number as the original sample. So 1, 2, 3, 4, 5, 6, right? And it's just 6 numbers picked out of those original 6, but with replacement. So what that means is sometimes you'll get a repeat. Like there's no numbers that repeat here. Sometimes you'll get a repeat even if there's no repeating numbers in here. So it's not like you pick each one out and then throw that one away, and then you've got one less in the bag. It's before you pick each time, you put the number that you picked before back in the bag. So let's look at these different things and see if they could be bootstrap samples. Okay, that's what this question is about. So this is 1, 2, 3, 4, 5, 6. That's the right number because this has a 6 numbers in it, right? That sample. Now we have to make sure that each of these could be picked from there. 75 could be picked there. You see they picked 67 3 times, but that's okay because 67's in the original sample. They picked 71, 71's in the sample, and so is 70. So yes, this could be a possible bootstrap sample. Okay, could this be a bootstrap sample? Well, let's see. Does it have the right number of data points? 1, 2, 3, 4, 5, 6. Yes, it does. So that's good. But we also have to check and see if all the values come from this. So 71's good because that's in the original sample right here. 68 is not, right? So this couldn't be a bootstrap sample because there's a value in this sample that's not in the original sample, right? You can only pick from among these numbers. Okay. Is this one? 1, 2, 3, 4, 5, 6, 7. Remember, and there's only 6 numbers here. So this bootstrap sample is not a bootstrap sample because we've got too many numbers here. Oh, it's already selected for us. No, the sample size is too large. Okay. Now let's check this one. 1, 2, 3, 4, 5. So this one's too small, right? Because this has 6 and this only has 5. So where's that? The sample size. Oh, it's A. No, the sample size is too small. Okay, last one here. 1, 2, 3, 4, 5, 6. So it's got 6, which we need. Okay, let's see if all the values come from the original sample. 63 is good. 71 is up there. 70 is up there. And 71 again is up there. So this is good. So I hope that helps you. You need to check 2 things to be able to get these questions right and figure out if these are samples. Now, bootstrapping, what you do is you take a whole bunch of these samples, of good ones, right? And you create a distribution from that. And that's the power of bootstrapping.